10,000th of an inch. So if I went down to next one down, that would probably be fine. I can't imagine anything's going to show up there.
The R&D shop is staffed by professional machinists, and when we're in research, we create new experiments to try and drive the boundaries of knowledge, and sometimes that means new kinds of machines. In order to build those machines, physicists are not generally trained at the same level as a professional machinist at an R&D shop. Sometimes we need things machined to very fine precision, precision that can only be done at a shop that we have at Berkeley. And so it's not just any machine shop that could do it. It's specific to the skill set of the machinists here. So that's everything from how experiments that have to be built in very small scales, or have to have very well-defined curvatures, or tolerances that are really unimaginable but possible at this machine shop. But that's really to create new experiments that enable our scientists and researchers to really push the boundaries of knowledge.
We can program something that's a complex shape and make it on a computer-operated machine, as well as just walk over to a simple machine and make something by hand very rapidly. So we have full range, full spectrum of equipment. And each one of us can operate almost every machine in the shop, so we can cover each other. If one person is busy, the other person can do the same work, and we can work together on projects and just make everything happen very efficiently. We have manually operated lathes and milling machines, drill presses, grinders. We also have an EDM machine, which is an electrode discharge machine, which can cut through conductive material with a brass wire and make very complex shapes very accurately. And we have newer computer-operated milling machines, both 3-axis and 5-axis controls. So you can make something that is like a 2-dimensional shape with a spindle that goes up and down to create the 3rd dimension. We also have a machine that has 2 more axes of rotation, which can rotate the blank as the X, Y, and the Z are moving at the same time. So complex shapes can be made with that by a computer program. I think that the thing that's most fun for me as a machinist is that you can take a raw piece of material, and by using the machinery and the creativity of your thoughts, you can turn it into a physical object that maybe never existed before. I've made parts that other shops say can't be made, and just because I'm willing to take a chance and do something different. And that's the spirit of the physics department, is experimentation, where you take an idea and turn it into a physical reality, even if it's never existed before. And that is totally possible. So for someone who doesn't know that's possible and it excites them, this is a good place to look around and learn from.
It's really useful to be able to just come down 2 flights of stairs and talk to the person who's making your device, right? If we had to outsource this to some outside shop, first of all, it's not even clear that they'd be able to do it. We've asked other shops before, we've sent them our drawings for our parts, and they say, no, we can't do this. This is too difficult. But even if we could find a place to do it, the sort of back and forth that you have with the people down here is one of the best things about having this resource.
Yeah. I don't think I've ever had to have them remake anything for me. It's just sort of like, you talk to them, they figure out what you want, and then it's one and done. They deserve a huge amount of credit as machinists and as experimentalists, I would say, too.